Hello everyone, my name is Emiliano Larach, and today we're going to be looking at lab number 3 of Physics 2211 with Dr. Flavio Fenton when we're talking about black holes. The objectives of this lab are to analyze the trajectory of a star around the black hole to determine the mass of the black hole using net force and gravitational force equations, and also to find the initial velocity a ship needs to have taking off from a planet to avoid crashing back again with the planet or getting engulfed by the black hole. For the first part, we are calculating the mass of the black hole. For this, we simply use the general gravitational equation and we solve for m2, which would be the mass of the black hole. And we have m2 equals dp/dt, which is changing momentum over changing time, times r squared, which is just the distance, divided by g m1, which is the mass of the star that we are given. The initial conditions are just constants and the mass of the star we were already given. And also for the while loop of the first part, we first calculate the momentum, the p initial and p final, then we calculate the change in velocity and momentum, subtracting the final minus the initial, and then we apply the momentum principle to find dp/dt, which is delta p, which we calculated before, divided by delta t. Because of the momentum principle, we can equate F net to dp/dt, and now we have the net force in this system. Now that we have dp/dt, to find dp/dt perpendicular, we first find dp/dt parallel because we know how to calculate that. It would just be magnitude of p final minus magnitude of p initial. That's just delta p of the magnitude, delta of the magnitude of the momentum divided by delta t. And now that we have dp/dt parallel, with that we can calculate dp/dt perpendicular by subtracting that from the total, F net that we calculated before. And now that we have both components of the momentum, we can calculate the perpendicular force, which is b dp/dt perpendicular to. We here have the equation to calculate the parallel component, which is delta of the magnitude of the momentum that's divided by delta t times p hat, which would be just the unit vector of p. To calculate the mass of the black hole, we simply use the equation that I showed before here in this slide, and we got that the mass of the black hole was 1.337 times 10 to the 34, and we also got F net parallel, and F net perpendicular. As you can see in this illustration, we can see that the arrows, which represent the F net parallel and the F net perpendicular, get way bigger as the planet get close to the black hole. That's just because the distance is smaller, so the force is bigger. Now we just want to get close. Now we have a ship. We are inside a planet, and the motors fails when we're trying to get outside of the planet. So now we have to find the force to get which initial velocity do we need to not get engulfed by the black hole, and also to not crash with the planet. So we simply use the same principles from before using the gravitational equations. And now we have the mass of the black hole. Now that we have the mass of the black hole, we simply calculate all of the net forces. First, the F grab on the planet by the black hole, on the planet by the ship. We calculate the net force acting on the planet and the net force acting on the ship. And now that we have these two net forces, we can use Newton's second law in this position update form to calculate how this will move. And in the previous part that I didn't mention was that the ship speed that we're using in this part, we found it using trial and error. So by using these speeds, we can see in our simulation that the ship, which trajectory is the magenta line, just slightly hovers around the black hole, but then it goes out and the planet is just circling around the black hole. So what does this mean? In your analysis, what is the difference between the net force and its parallel and perpendicular components and the rate of change of momentum and its parallel and perpendicular components? So the main difference is that the change of momentum we can calculate, and the net force is just the sum of all of the forces. So we use the change in momentum to calculate the net forces. So it's important to know that difference. And also, now we know at what velocity do we need to start to just leave the black hole. But what now if we want to start in an orbit around the black hole? Well, we are physics master. We can calculate that. For that, I just use more trial and error, and I just reduce the initial speed of the ship. I just reduce it by 1 exponential, and we can see that now the ship, which has the magenta trajectory, just enters in an orbit around the black hole, and we can see the planet still the cyan trajectory. So that will be all for my presentation. I hope you liked it and you understood everything that I explained. And thank you very much for watching. See you in the next lab. Bye.